In today's lecture, we will cover two basic counting principles, which is addition and multiplication principle. So to understand these principles, let's consider an example. There are 5 Spanish books, let me call them S1, S2, S5. 6 French books and they are different. So F1, F2, F6 and 8 German books. How many ways of there to pick an unordered pair? Unordered means that S1 F5 is equal to F5 S1. So we need to pick two books not in the same language. So if we simply start to solve this problem, I start with S1, F1 and start making pairs and so on. So with S1, the number of the pairs which are formed is 6, then again 6 and so on, which means that from S and F, it would be 5 cross 6. Similarly, from French and German, it would be 6 cross 8. And from Spanish and German, it would be 5 cross 8. These are the total possibilities. And if I have to compute the total number of the possibilities, then of course, since each one is independent of each other, I must add them. So the answer is 30 plus 48 plus 40. So two things to observe here is that we have used multiplication principle and we have used addition principle. So addition principle says that if there are R1 objects in first set, R2 in the next set and so on, and if different sets are disjoint. So in the previous question, the three sets were, the first one is 5 cross 6, the next one is 5 cross 8 and 6 cross 8. So 3 sets were there because each one is giving you the output. So you can say that to compute output, you have considered 3 cases, case 1, case 2, case 3, and all cases are disjoint. That's why you use the addition principle. Multiplication principle says that to get the output, you break it into the successive stages. So like in the previous example, there are only 2 stages. You pick one book from French and one book from German, let's say. So these 2 stages are there and in total they are giving you the outcome. So in that case, we will use multiplication principle. Things would be more clear when you see the other examples. So how many ways are there to form a 3-letter sequence using these 6 letters, where the case 1 says that repetition is allowed. So let's say 3 letters are like this and repetition is allowed. It means that the first position can be filled in any of the 6 ways, which means any one of these 6 letters can be placed here. So there are 6 ways, and similarly 6 ways for the remaining 2 positions. So in total, we use the multiplication principle to have all possible ways to form a 3-letter sequence without repetition. Now when we say without repetition, it means any one of the position, we can pick any position, doesn't matter. Let's say you pick this one, so it can be filled because this is the first position, so all letters are available to you. But once you use a letter at this position, then that same letter cannot be used again, which means after using one letter at this position, there remains 5 available letters. And once you use, let's say use A here and C here, then A and C cannot be used for the last position, and therefore in this case there are 4 positions available without repetition and containing letter E. So try to solve it by yourself. Now containing the letter E, when it says, then letter E can be at any of the three positions. Let's say it can be here, it can be here, and it can be here. So now there are three different cases, and when different cases are there, addition principle will come into the picture. Now E has already been used. It means for this position 5 letters are available, and for this position 4 letters are available. So you use the multiplication principle and then the addition principle. The last case says that with repetition and containing letter E. Now repetition is allowed. So again there would be three cases, and E could be at one of the position. So let's say E is here, E is here, and E is here. Now one common mistake which we can do is that when repetition is allowed, we may say that there are 6 positions here, 6 possibilities, and total answer is 36 multiplied by 3, which is 108, but it is incorrect, because let's say E is here, you filled E here, and you filled F here. In this case E is here, E can take a position here, F is here. So there is a repetition of cases, and this creates the problem, because we need all outcomes to be disjoint or distinct. So it means that we need to think a little bit differently. So if I try to solve this one, then 3 positions, E is here, E is here, and E is here. Now without repetition, it means that for the remaining one, with repetition, it means that E containing E, so I can use 6 here and 6 here. So this is 36. Now since to avoid repetition, I cannot use E at this position. So it means that only 5 letters are available for this position, and 6 can be used here. So this is 30. And now E cannot be here, E cannot be here. It means that only 5 letters can be used at first position and 5 can be used at second position. So it's 25, and if you add them, the answer comes out to be 91. We'll quickly go through this question where we discussed without repetition and containing the letter E. Now one approach which we have used is simply the addition multiplication principle, but here we can introduce the subtraction principle as well. Now subtraction principle says that we need to compute containing letter E, but if I do the contrapositive of this problem, say without repetition and not containing letter E, so what will happen? If letter E is not allowed, so you have the possibilities as only 5 letters are available, and it's without repetition, so 5 cross 4 cross 3. Total outcomes are 6 cross 5 cross 4, so you subtract 5 cross 4 cross 3, because you have considered not containing letter E. So if you consider this case, because sometimes computation is easy when we consider this case, so total outcomes minus not containing E. This also gives us the required answer. So in the next class, we will discuss at least 3-4 more questions which are based on addition and multiplication principle. Thank you.